Aloha and welcome to this screencast about the RESTlet framework. This is actually the second screencast on the RESTlet framework that I'm giving to you. If you haven't seen the first screencast, which talks about REST in general, and my example program called the RESTlet date service, you should definitely go check out that one first, okay? Because I'm gonna expect that you guys have all watched that first one and have played around with that particular framework when I'm introducing this one here, because I'm going to skip over a lot of stuff that I covered in that last screencast. I'm really excited about this lecture because in this lecture, your screencast, you're going to start to see really the power of the REST framework. The RESTlet date service was pretty lame, if you really want to get right down to it, and this one is going to really start to show how an actual functional REST service looks. Okay, so in this particular screencast, the things I'm going to focus on are the REST concepts as implemented in RESTlet for getting, putting, and deleting resources. And then I'm going to spend some time showing you how you transfer a representation of a resource back and forth. And we're going to use XML as our representation. RESTlet has support for a lot of different kind of representations. You can represent your resources as XML. You can represent them as JSON. You can represent them as serialized Java objects. And HTML, so there's a bunch of different things different ways you can represent it. Probably the most common representation for resources in current web architectures is XML, although I will say that JSON is becoming increasingly popular. But we're going to start with XML. It's pretty easy to use, and it is the most popular one right now, so you'll get a lot of mileage out of understanding how to do XML support. Then I'm going to show you URI templating. This is a key issue with the RESTlet framework, which is how you extract pieces of the URL that the client sent you in order to understand what it is, what actual resource they want you to be dealing with. And then I'll show you how RESTlet does content negotiation. This is kind of a tricky part of RESTlet because what it basically does is it kind of auto-magically decides whether you want JSON or want XML or so forth based upon the way you defined your methods. So it's a little crazy, but it's actually pretty cool once you get it under your belt here. Okay, and so in order to illustrate all this stuff, I'm going to show you this date service example system that I've hacked together. We'll download the distribution. I'll show you how to run it from the command line, how that looks. Then we'll look through the various parts of the code. Now remember in our last screencast, just to quickly review, I don't think it was called time service. I think it was called date service actually, right? But you added in time mechanisms. So we had a server, and you could request things from the server, but you couldn't actually put anything on the server, which kind of sucks because most services you actually want to add things to. And the representation was just a simple string, which is okay, but still rather limited. And we only needed the single core RESTlet jar file. So we're gonna extend all of those things in the current system, which is going to support a very trivial kind of contact service mechanism. And the idea is that our server is going to allow you to add contacts, delete contacts, and retrieve a contact that's been previously put to the server. And we're going to represent a contact as a structured object that contains a first name, a last name, an info field, and a unique ID. I'm just going to wait for a second while our colleagues from the Honolulu City and County finish up outside. Okay, they've gone. And the third thing is that our contact service is going to represent contacts in two different ways. We're going to have Java classes, and that's what we're going to actually be storing in our backend repository, and then we're going to have an XML representation of the contact, and that's the thing that we're going to send across the wire to our client. So the structure of the system is there's essentially three package hierarchies. There's a server package, and that's going to contain all the code that's specific to the server side of our system. There's a client package hierarchy, and that contains all the code that's specific to the client side of the system. And then there's this third package called common, which is the code that needs to be both in the client and the server. And it's going to turn out that that's the Java the definition of the contact in its Java representation. Okay, so before we get to the actual code, it's useful to understand what the REST API for this system actually is. And it's super simple. It's just like one URL, okay? HTTP:, then whatever your host is, and then the context root, which is contact service, and then the resource. We only have one resource in the system. It's called a contact. And then the URL always ends with a string which represents the unique ID for that contact. So there it is. There's just, we got one single kind of URL. But we have three different kinds of operations that we can perform on this URL. We can get the URL. We can take this URL and perform the get operation, and what that's going to do is request to the server to get that contact, and if it exists, return an XML representation of it. The put operation is going to be, we're going to take the URL and we're going to include with the put operation a representation of the contact that we want to store on the server as the payload of the request. And of course our contact's representation will be in XML. Finally, there's a delete operation, which is you send the URL and you ask the server to ensure that there's no longer any contact with that unique ID being stored there. It's not an error to call delete with a unique ID that doesn't exist currently. Okay, so that's not an error. You're just guaranteeing after you invoke the delete that there is no longer a contact with that ID there, if indeed there was one to begin with. Okay, so there's a few different ways you can play with the system, and I recommend you do all of these things. You can build the jar files, or I guess in the distribution it comes with them, so you don't really have to build them if you don't want to. And you run the server jar file in one command shell, and then you bring up another command shell and you invoke the client with various parameters that allow you to add, put, and delete contacts. You can also use the build system to compile, run, see the coverage, build the jar files, and so forth. And then finally, you can use Eclipse. You can import this. It comes with the Eclipse.classpath and .project files, so you can import this project into Eclipse and then navigate around, and you can run the unit tests and so forth. Okay, let's get rid of PowerPoint and go to looking around and seeing what's actually happening. So the first thing you're going to want to do is download this sample system, and in order to do that you have to go to Google Project Hosting, to the ICS Software Engineering Examples project, and you'll go to the Downloads directory, and you'll see that there's the RESTlet date service, which is what we looked at before, but now there's going to be a RESTlet contact service, and that's the thing you want to download. Okay, and when you after you've downloaded it and unzipped it, you're going to see something like this. Okay, actually you're not going to see something like that. Let me just get rid of everything that was there. Okay, now you'll see. Oh, no wonder. I was in the wrong place. Okay, you'll see something like this. You won't see the subversion files, but you'll see something that looks very much like this, which is that you've got your build files and you've got a source directory, and If you want to understand more about these build files, you'll have to look at a previous screencast in which I go over them. I'm not going to go over them in too much detail today. But then we've got a source directory, and it's going to contain our system right here. Okay, so there's our contact service, client server, and common directories, as I was talking about before. The first thing you're going to want to do when you download this system is you're going to want to run Ant. The reason why you're going to want to run Ant is that we need some RESTlet libraries and other libraries in order to actually run this system if you're not running it from the jar files which already contain them. And so running Ant is important, and also if you want to look at it in Eclipse and do anything, you definitely need this library. And so you see, as a result of having run Ant, we now have this lib directory, and if we look in the lib directory, we'll see we have some config files, which is for our quality assurance stuff. We have JUnit, which we had to download in order to run unit tests, and we also have this RESTlet library. We have these 3 zip files which contain Java docs for the extensions jar file, so org-reslet.extension, and the core org-reslet.jar file, for which the Java docs are in this api.zip. Now the important thing I want you to see here is that in order to use the XML representation in RESTlet, we need something in addition to the core RESTlet jar file. So the RESTlet system is highly modularized, and you'll need to kind of go look at the RESTlet stuff if you want to go beyond the XML representation. So for example, if you want to use the JSON representation, you'll need to include an extension for JSON as a jar file that's included with your system. And RESTlet has, I don't know, 20 different plugins for all sorts of different kinds of capabilities. So that's a good thing, but it also makes the configuration process slightly more complicated than if they'd included everything in one Mondo jar file, but that would have had its own disadvantages. So I think they did the right thing. Anyway, the point being is that for this system, we're going to need 2 jar files. We're going to need an extensions file, which includes our XML support, and we're going to also need the core RESTlet API. Okay, so having said that, what I'm going to do now is I'm going to build the client and server systems. And so if we now go here, you can see I've got this RESTlet contact service client.jar, RESTlet contact service server.jar. And so let's just play with the system and see how it looks from the client server external perspective. In order to do that, what I'm going to do is run the server jar file in this command shell, and you can see it started up and it's on port 8111. And then in this one, I'm going to run the client jar file, and I'm going to start off by just running it without any arguments. Okay, and it's going to say, you need some arguments here. And the way that this client is set up is that you always have to supply a host. Then you have to supply an operation, either get, put, or delete. And then you have to supply the unique ID of the contact that you want to get, put, or delete. And in the case of the put operation, you then have to supply the first name, the last name, and the info fields for that particular contact. So what I'm going to do is start off with a put. Okay, and what you can see here is I'm going to say java-jar RESTlet contact service.jar. Then I'm going to supply the host. Excuse me. Then I'm going to supply the operation that I want to do on the URL that I'm going to construct, which is put. And here's the unique ID for this contact that I want to put, which is PMJ. Then I've got the first name, I've got the last name, and I've got the info field. Okay, so in this case, I'm going to put a contact whose unique ID is PMJ and whose details are Philip Johnson, professor. So let's see what happens when I do that. Okay, what you can see is the contact, the client spits out a little stuff that it's working. These are the RESTlet log stuff, and then just returns, which indicates that everything went good in the case of this client. Okay, down here on the server side, you can see that we got a log message saying that there was a put command received. Here was the URL, and 200 was returned, meaning that everything was successful. Okay? So now we put a contact on the database. Let's try to get it. Okay, so in order to get it, what I'm going to do is I'm going to supply the host, the operation get, and then all I need is the unique ID in order to retrieve it. Okay, so if I provide those command lines, what I can see is I get those same two logging output lines, but then this client is also going to print out the two-string representation of this Java object which it's received. And so that just shows that the ID was PMJ, the name was Philip Johnson, and the info field was professor. So it's all G. Okay? Lastly, what we have delete we can also do, so we can try that. Let's just go here and let's try to delete. Oh, and by the way, after our previous one, you can see another line of logging output. Now we have a get command. Here's the unique ID, returns 200 saying yes, all fine. Okay? So we'll try this delete command. And the delete command worked fine. And we can see down here that we can call delete, and it returns 200, meaning successful. The status is successful. And here was the URL. By the way, we can also call it again. Okay, and you can see everything is still good, right? So you can call delete repeatedly without any problem, because the semantics of the delete command is simply to make sure that the thing isn't there. So if the thing's not, if the thing's already not there, then you can call it again, and there's no problems. Okay, so the last thing you might want to see is, okay, we know we don't have that PMG anymore, PMJ contact anymore. What happens if we try to get it? So here's what happens when we try to get it. We try to do a get. Here's the unique ID. The system's going to return 406, which means that was not an acceptable argument to the server, because that PMJ is not a unique ID that actually exists in the system. So we get an error returned to our client. There's the status code 406. Okay, and so here you go. You know, you got your server. It can store contacts. You can add them, delete them. Now, in order to make this example simple, there is no real persistent store associated with this server. So if once I do a Control-C to get rid of this server, any contacts that were in that server are now gone. Okay, and you start over from scratch. And that's nice, because it just means that there was a lot less coding, and for the purposes of this example, I'm not trying to teach you about persistency. So there's no point in burdening you with that extra code to look at. You can add in persistency if you want to. In fact, that's a great idea. I'll probably make you do it in the future, but for right now you don't have to worry about it. And I hear our city and county employees for Honolulu are coming back up the street, so it's going to get noisy here in a second, but we'll press on. Okay, so you've seen the command line client. Now what I want to do is go into Eclipse and start showing you the internals of the system. Okay, I'm going to start with the build.xml file. Actually, we'll just pause for a second here. This is what happens when you do screencasts on Saturday morning. Okay. The first thing is, the main thing that you want to see about the build file that's different from the original screencast, the date service, is that in my Ivy line that is retrieving the RESTlet module, I'm retrieving two configurations. The default configuration, which is going to retrieve the org.restlet.jar file, as well as a configuration called XML, which is going to retrieve the XML extensions jar file. Okay, so this is really important when you're trying to use any of the extensions to RESTlet. You've got to make sure that you get all of the required libraries and their dependent libraries. Okay, and using an Ivy-based system, then you want to make sure that you retrieve the appropriate configuration for that. Okay, so that's the build file. The next thing I want to show you is the set of packages in the system, and you can see we have a client package, and that contains just a single class, which is the contact client class, which implements the client. We've got a common package common.contact, and that implements the code that's shared between the client and server. And what is shared is actually the Java representation of a contact. And then finally, we've got the server package hierarchy, and that has a few different subdirectories. One is it's got the class that implements the server, the HTTP server. It's got a class that implements the back-end quote-unquote database or repository for this system, which is called contact. So it's basically a class that implements a collection of contact instances. And then we've got a resource sub-package hierarchy. In this case, there's only one resource that's available at the current time, and that's a contact resource. All right? So let's go through these classes in a little bit more detail. The first thing I want to show you is the contact class, and this is starts off, you might think, is just kind of a simple, almost like record type class, which implements a first name, last name info, and unique ID, and that's true. Okay, so that's kind of the Java representation. But then there's also, this class is also kind of cool because it implements the XML representation of a contact as well. Okay, so I'll kind of go through this and show you how that works. We have a constructor for the class, which is the kind of constructor that you would expect from the Java side, where you pass it the first name, last name, info, and unique ID, and it sets these fields appropriately. Okay, and then I also have one accessor function, which is get unique ID, that returns it. I don't implement a get first name, get last name, get info, because for this very simple example, I don't need to call those methods. And in any realistic situation, obviously you want to be able to get at the contact info, but the only field that we really needed for the purposes of this example was the get unique ID. So that's the only one that I implemented. I also created an overrided toString method to print out the contents of this contact in a nice way, and you can see that here. And remember, in our client up here, where is it? Okay, there's an example of that toString method right here. Okay, going back to here. Okay, we override equals and hash code because we're going to be storing contacts in a collection class, and if you're going to store things in a collection class, you always have to implement these things. Okay, and here's where things kind of get cool, which is that in addition to the toString method, all right, which returns a string representation, we're going to implement a toXML method, and that's going to return the XML representation as an org.w3c.dom.document object. Okay, so you're going to see DOM and documents being manipulated and named in various situations in this. So whenever you see DOM and whenever you see document, just think to yourself internally, oh, that's XML that they're talking about right there. Okay, and so it turns out that to create an XML representation using this DOM representation, I'll say that Java builds in two classic ways to represent XML. One is called DOM for, I think it's like document object model, and another way is called SAX, which is, I don't even know what that stands for. Okay, but the difference is that when you're creating DOM representations of XML objects, the entire object fits in memory. Okay, and it's a simpler interface. As you see as we go through it, it's totally easy to understand how it works. The problem is that it's possible to have these gymongous XML objects, which can even exceed the size of your memory that you're allocating to your process, and so then this DOM thing doesn't work so well. Okay, and in fact, it may be the case that you have some gymongous object, and what you want to do is you really want to only extract one tiny little piece of it. Okay, but using the DOM object, you'd have to read the whole gymongous thing into memory just to get at that tiny little piece, and that's kind of stupid. So then they implemented this other thing called SAX, which is a way of not having to read in the entire XML object in memory. Instead, you leave it out on disk, and then you have these like little event guys that kind of go out and retrieve only the little pieces that you're interested in at the moment. Okay, that's a more complicated interface to use and understand, but of course it has this efficiency advantage in the case of gymongous XML objects. Okay, so of course RESTlet has support for SACs as well, but in this particular example, since our XML objects are tiny, we're just going to use DOM because there's basically no disadvantage, and it's a simpler thing to look at. Having said it's simpler, it's not completely simple. All right, it turns out that Java, in its infinite wisdom, has implemented this kind of Baroque way of dealing with creating documents, where you have to have this document builder factory, which is followed by creating a document builder, and then you finally take the builder and you create this new document, and so it's all interfaced out in order to like swap the implementations and blah blah blah. Okay, that's all good, but you basically this is just magic lines, boilerplate code. You just put that in there, finally get your document object, which is what you want. And here's where things get a lot easier. The idea is that XML, of course, is this hierarchical thing. It's a tree-like structure. So the first thing you do is, and each kind of element of your XML is called an element. Okay. And so you create these element objects. We'll have our root element object, which is going to be contact, and then we will append that root element to our document. Okay, so now we have a document with an element in it, which is a contact XML element, and then inside that we're going to create and attach elements for the first name, last name, unique ID, and info fields. And in order to not be typing those strings in various places where I need them, I've defined them up here. Okay, so there's a unique ID element, a first name element, a last name element, and an info element. Okay, so I've created a little helper method here called attach element, which takes the document object, takes the contact element, okay, and then given a particular element name and the particular value, we store it in there. Okay, and here's what that attach element thing is. You just create the element object, you set the text content to be the value, and then you append that child element to the parent. So it's really pretty trivial. So as a result of having done this, we've built up our XML document, and I realized I should have really documented what this thing kind of looks like in XML, and so I'm just going to type it in right now, right in front of you, and I hope this works when I Java doc it. We'll see. So it's going to look like this. It's going to say contact and then /contact. That's our outer XML, and then inside it there'll be first name Philip, first name, last name Johnson, last name, and then info, professor, info, and then unique, what is it, ID, how does that look? Yeah, unique dash ID, PMJ / unique ID. Okay, and then so the pre field, of course, is just to so that in the HTML we can actually include these angle brackets. So that's what a contact field. That's what the contact looks like in kind of raw XML. And then we're creating this document object, which is going to represent that in this particular method here. Okay. Now let's see, what else do we have here? Okay, so now that you've seen that, I can show you another constructor, which is a contact constructor, but it takes an XML representation of an object rather than the various string constituents of the object. Okay, so this takes the XML representation, and then we use this little helper method, which you can go look at down below, to extract the first name from that document object, the last name, the unique ID, and initialize the fields of this contact object to its associated its associated fields. Okay, so we've got one constructor that creates Java docs. Excuse me. We've got one constructor which creates contacts from strings. We've got one constructor which creates contacts from XML, and then we've got a method that you can invoke on a Java representation of a contact object and produce the XML representation. Okay, so the net of it is that this contact class allows kind of bidirectional transformation of contact information back and forth between Java and XML. We can go from XML to Java, we can go from Java to XML, okay, as well as building it just from the raw strings. Okay, so having said that, let's look at the test contact unit test, which makes sure that things work. So we're going to create a contact, passing in the string stuff, the first name, the last name, the info field, and their unique ID, which we're going to call ID. We can get the XML representation by invoking the toXML method on that. So now we've got this document object, which is an XML object. Then we can pass that XML object into the constructor for contacts to create a new contact object, which has been produced from the XML representation of our original contact object. And then we can just do an assert equals to see that those two things are actually equal. So just for grins, let's try to run that, and we can see very instantly that passes. Okay, so that's the key of our system. And just going back to the package, what you should see is that that's in the common package, because both our client and our server are going to use this contact Java class to support the functioning. Okay, let's now look at our, well, actually next what I'll do is let's look at the contacts class, just so you get that here. So on the server side, we need a way to store one or more contact IDs contacts that are being sent to us by the client. And so I implemented this simple class called contacts, which represents an in-memory representation of all the contacts that have been provided to this service. It does not implement persistency, so as soon as your contact server goes down, all the contacts that you've stored disappear. So I do not recommend that you use this service for mission-critical applications at the moment. Okay? An interesting thing about this is that the collection needs to be thread safe. Okay, it's very important because the RESTlet basically handles each request sent to the service in a separate thread. So there can be multiple clients sending gets and puts and deletes which impact on this repository virtually simultaneously, or at least concurrently. So a new request could come in while an old request hasn't finished processing. So you've got to make sure that any repository database thing is thread safe. Okay, now normally you're going to use an actual database mechanism like Derby or MySQL or Berkeley DB or something like that, and that's going to take care of this thread safety problem for you. But in this case, we're just using this in-memory thing. So in order to make this thread safe, what I've done is I'm using an underlying data structure which is thread safe called concurrent hash map, and then I'm also synchronizing all of the methods. Okay, so that each of these methods has to finish processing before the next one starts. Now, the other thing that you need to know about this particular collection is that it's a singleton. Okay, so it would not be good if we had multiple instances of the contacts collection class running around inside memory, because really we only want one of them to be there. So we're going to guarantee that. And the way that you implement a singleton class in Java is you have an internal private instance, okay, which is the only instance that's going to exist. You make your constructor private so that no clients can ever actually create a new instance even if they tried. And then we implement this public static getInstance class, which enables people to get at that singleton instance. Okay, and so this works because basically what happens is that when you define the class, you're creating this instance, this static instance. So there's no way for two of them to exist. Singletons generally are not the best idea because they create a bottleneck in your system. As you can see, this is a giant bottleneck. As our system scales up, every request has to go through this singleton instance of the contacts class, and so so if we were handling thousands and thousands of requests per second, I doubt this would work very well. Of course, this class has even bigger problems as a storage manager, in that once the system goes down, you've lost all your data anyway. So the bottleneck issue, performance-wise, is really the least of our problems at this particular situation. Anyway, what does this thing do? We've got this single instance of a contacts class, and what can you do with it? You can get an instance. You can get the singleton instance, okay, and you have to do that every time to get the thing that you're going to operate on. And then to that singleton instance of the contacts class, we can add a contact, we can get a contact, we can delete a contact, and then we can get a snapshot of all the contacts that existed in the system at the time this was called. Although a second later, it could be different. And we're not going to really use this one in this particular system, but in the katas, I'm going to have you do some stuff which might require you to use that. Who knows? Okay, so that's our contacts class, and probably just to cement your knowledge of how this works, let's look at the unit test. I find unit tests are really useful to explaining to another developer how it is that this system's supposed to work, because basically you exercise the API kind of in isolation from other stuff. So I really recommend that you do unit testing, not only because I require it, and not only because it's a good thing in terms of checking the correctness of your system, but also because it provides a convenient form of documentation, which I'll show you right now. So in our test contacts class, we've got, first of all, we've got to get our singleton instance of the contacts class, which is what we do here. And then what we got to do is we're going to create a contact to add to it. So the unique ID is going to be PMJ. We create a contact, first name Philip, last name Johnson, info field professor, unique ID PMJ. And then we add that contact to our contacts repository using that call there. So the next thing we want to do is we want to check to see that we can get we can get that contact that we've just added out of the repository. So this assertion says, let's check retrieval. So what we expect to get back is the contact that we've just created. And what we're actually doing is retrieving from the contacts repository get contact with unique ID, and hopefully those two things will be equal. Okay. We also want to check that if we try to retrieve a contact that's not in the contacts repository, for example, a contact with the unique ID foo, that this should return null. Okay, that's its behavior when it doesn't exist. And then we can also get all the contacts in the system, and that forms a kind of a snapshot of the repository at that moment in time, and we can check to make sure that there's only one contact in there. Finally, we can call the delete contact with the unique ID, and then make sure that it's actually deleted by retrieving that, trying to retrieve that contact from the database and making sure that null is the value that we get back. Okay, so there it is. You've got the ability to get a contact, add a contact, and delete a contact, and then get a snapshot of all the contacts. So let's just run this to show you that it's green, so all of these things actually work. Good news. Okay, so I've shown you this contact object. I've shown you the repository that holds contact, a bunch of contact objects. Now let's get to the REST part, which is starts with this contact server. Okay, this contact server is going to look like our date server from the first RESTlet example. It's going to look almost exactly like it. We've got this run server method, which takes a port and starts up a RESTlet application. This is going to look really pretty much exactly like the other one. We're going to create an instance of this class, okay, and we're going to attach it to our default host. Our contact root, instead of being date server, is going to be contact server, okay? But otherwise, this is pretty much exactly like the other one. The main method is exactly like the other one. We're going to call our run server method and pass it the port to be used when we're running it from the command shell. In this case, it'll be 8111. And then we've got this inbound root, which is the way that we specify the legal URLs that we can send to this server. And this is where we're going to have something kind of cool and new that you haven't seen before, which is that we're going to specify a template. Okay? So we're saying that we're going to attach to our router this resource name, which is contact, but then following that in these curly braces, we're going to have a variable, essentially, which is going to be bound to that value that follows that position in the URL, and is going to be, and that, in terms of our RESTful API, specifies the unique ID associated with this particular contact. Okay, because remember, every URL, whether we're doing a put, get, or delete, has to specify the unique ID of the contact. Okay, and then we're going to send off, if we get a URL that matches this particular specification, we're going to send it off to our contact resource class for processing. Okay, so that's that. And let's see what happens when we get a URL that looks like that. We're going to go to this contact resource class, and the first thing I want to direct your attention to is the fact that this contact resource class, it implements server resource just like in our old system, and it implements exactly 3 methods. One method, which is going to process GET requests because it's been annotated with the GET annotation. There's a second method called put contact, which is going to process put requests because it's been annotated with a put. And then, as you might already be guessing, we have our delete contact method annotated with the delete annotation, which means that this is the method that's going to be called when the operation is delete. Okay? So pretty cool, right? I should say just extremely straightforward. All right, you know, if you understand the REST API and you understand what the system's supposed to do, following the control flow is quite obvious, at least to me. Okay, so let's first look at the get contact method. Okay, remember, when we have a get contact method, what are we supposed to be doing? The client has sent us a URL, and basically they've sent us the unique ID. They want back the XML representation of that object as it exists currently in our backend database. So how do we actually do that? Pretty simple. The first thing we got to do is we're going to create the get contact. The get method in a server resource class has to return an object of type representation. Okay. Or throw an exception. Okay, but in normal courses, when you do get, you're trying to get something back from the server. What you're actually asking to get back is a representation of a resource. So we're going to return a representation instance. See, that's should be pretty self-explanatory, almost self-documenting. Okay, so and there turns out to be representation is a superclass with a lot of subclasses. What we're going to actually return in this case is an XML representation, which now remember, I kind of reminded you before there were like DOM and SACS. There were like different kinds of ways you could represent XML. So it turns out that we're not going to return an XML representation, which would have sounded a little more straightforward. We're actually going to return a DOM representation, which is the one representation of XML, which is itself an XML, which is itself a representation. So anyway, we're going to create this DOM representation object that's going to hold our result. And then the second thing we're going to do is we're going to try to find the Java object corresponding to that unique ID. Okay, and we got to do that 2 steps. First, we got to find out, well, what was that unique ID that was in the URL that the client sent to us? And we retrieve that via this special magic. Okay, we invoke this method called getRequestAttributes, which returns a map of the template strings and the objects they were bound to. Okay? Remember, if we look back in our contact server, we had this thing called unique ID. That was our little parameter value or template variable that's going to be bound to the string that occurred at that position in the URL. If we go back to contact resource, we use that exact same string to say, give me whatever was in the URL at that particular place in that template string. Okay, so that's going to give us what the unique ID was from the URL. Okay, now that we got this unique ID, we just look up in our contacts database whether or not that thing exists, right? And remember, it returns the Java object. If it exists, it returns null if it doesn't. So the first thing we do is we check to see if it's null. If it's null, what we're going to do is we're going to set the status. Remember when we looked here, we saw these status codes, and 200 means it's all good. 406, something other than in the 200 series, means there was an error. So when we did something wrong, we returned to 406. Okay? Here's where, in the case of an error, we're going to explicitly set the status field to be 406. It turns out that that's the one for that is 406 as a numeric value. And that's all we actually have to do, okay, in the case of an error. If the contact field is not null, in other words, contact is a Java object, then what we can do is we take that Java object, we invoke the toXML method, which returns the XML representation as a document, okay, which is very convenient because the result representation has a setDocument method which can be passed a document object and will set that representation to be that thing. Okay, so now we've just filled our result DOM representation object with our XML representation of our contact. We don't have to set the status field because RESTlet will set it to 200 if we don't tell it to do anything else. Okay, and then we just return that DOM representation object, which will either be empty in the case that the status field is set to be an error, or will actually contain our contact object in the case that it existed. Okay, so clients have to be careful to always check the status value in the case of REST architectures to know whether the representations that are being returned are valid or not. That's just part of the architecture. Okay, so that's how the get field, that's how the get contact representation works. Let's now look at put. Remember, in the case of put, the client is passing us the XML representation of a contact instance, and our goal here is to shove that thing into our backend repository. So how do we do that? Well, we've got this put method. It's always passed a representation because obviously in the case of puts, you are generally supplying something that you want to put. It returns a representation which is to take care of some bizarre boundary condition. I don't really know where you'd ever want to return a representation after a put, but I guess in case you want to do that, you can return a representation object. But generally, the put is going to be passed a representation. And so, how do we do this? Well, we get this, kind of this top-level superclass representation class, but we know that it's an XML object. And so, what we're going to do is we're going to use the DOM representation constructor that's passed a representation object to return a new DOM representation object, which is an XML object. Then what we can do is we can call the getDocument method of our DOM representation. That returns our XML representation of a contact, okay? And we can pass that to our contact constructor, which takes XML objects. Totally cool, right? And what does that return? Well, that returns our Java object for contacts. Okay? Once we've got that, then it's very easy. We just call the addContact method to pass that thing into our repository. If the thing already existed, if the unique ID was already in there, it's going to be overwritten. Okay, so that's all good for our particular semantics of this class. And then we return null as a representation because for puts, there's no need to return anything representation-wise. And the system, RESTlet will use the status code 200 if everything worked okay. If for some reason something went wrong and we throw an exception, then RESTlet will automatically return error code representing that something bad happened on the server side. You could catch exceptions if you wanted to in here and set the status string explicitly yourself if you wanted to do that and provide more details about what happened. Finally, let's look at our delete method, which deletes a contact. How do we do that? Well, all we need to do is we need to get the unique ID out of the URL using this kind of idiom here. And then, given that unique ID, we just invoke the delete contact method of our contacts database to make sure that it's no longer there, and then we return null. Very simple. Okay, so now you've seen the entire server side. Okay, whoops. The last thing that we want to look at is the client side. How do we implement the client? Okay, and maybe before we do that, let's just go back here and whoops, let's go back here. Let's fire up our server again, and then you can remind yourself that like we can run a get method and with just passing a unique ID, or we can run the put operation passing a unique ID, the first name, last name, and the info field, and in that case, you know, we send the put operation and so forth. Remember, so we got these arguments for get and delete. We just pass a unique ID. For in the case of put, we have to pass unique ID plus the actual payload that we want to have passed. So how do we implement that in Java? We use a class like this. Here's the main class that's invoked. The first thing is we just check to make sure we have at least 3 arguments, because we always need the host, the operation, the unique ID. This isn't that good for error checking, because if we were doing a put, we'd really have to have these optional, we'd have to have these put args as well, and I don't really check for that, but oh well. So the first thing is we want to figure out what our URL is, and that's going to consist of the host plus the context root, which is contact server, plus the resource, which we know is contact, and the unique ID, which is that argument right there. And we just concatenate all those things together. There's our URL that we're going to be passing, and we create a client resource object with that URL. Okay? So there we got our client, and then given our client, we want to basically invoke get, put, or delete on it. Okay, so let's see how that works. Well, we're going to get the string value that I passed, which should hopefully be either get, delete, or put. If it's not, then you know nothing happens. It silently, exits. If it's a get, if we passed in a get as our operation, then what we're going to do is we're going to call the get command on our client. That invocation returns a representation object, which we're going to now pass to our DOM representation constructor, which will return the XML representation object that we want, which is right here. And then we can get the document object out of that representation, which is an XML representation of our contact that we've got from the client. Okay? And we pass that to our contact constructor. So now we've got a Java object that's the contact that we've requested from the server. And this is, and then we just, call the toString method and print it out. Okay? In the case of the unique ID not being present on the server, the contact.getCall will throw an exception. Okay? So if it doesn't get back a 200 style value, if it gets back 406 or whatever, it'll throw an exception, and then we'll go down here because we got this resource exception, and it will print out what actually happened, or what the status code was and why things didn't work. So we'll never get to these lines of code in the case that we don't get back a representation from this client.get. If it's the delete, it's very simple. We just call delete because our URL includes everything we need to know to do a delete. And then if we have a put, okay, we've got to take our additional arguments, our optional arguments, and the unique ID. We construct a contact object in Java from that. Then we create a DOM representation object, and then we set this DOM representation object's internal document field to the XML representation of our Java object. Okay, and then finally we call the put command, or the put method of our client resource object with the representation that we've constructed, which is the XML representation of the Java contact, which we created on this line here. Okay, so there's a little bit of going from strings to Java, from Java to XML, and then we send it, and then we get to the client, and then we've got this XML, and then we convert it back to Java, and so forth. But hey, that's just how it works. Okay, or that's it's a clean way. There's a little bit of, it's maybe not completely optimized, but then again, computers are pretty fast these days, and if you want to, if you really want higher efficiency, one thing you could do is you could represent your objects as serialized Java objects, okay, which then you could, just serialize them. That's super fast. You send them over the wire. That's super fast. And you can reconstitute them as Java objects on the other side, and that's super fast. So that would be very high performance. There's a downside to that, which is that both the client and the server have to be Java. Okay? What's cool about using XML is that even though in this case I implemented both the client and server sides in Java, you don't have to have the clients be Java based if you're sending XML. So I could have a Ruby client that constructs an XML object that conforms to our structure and then sends that across the wire, and that'll work just fine. So that's one of the reasons why I wanted to show you this XML representation, is because it creates kind of language independence, and that's one of the big things about XML in general. Okay, well, I think at this point that I've pretty much covered everything that I want you to see for this particular service. Actually, I'm going to show you one final little groovy thing here that I didn't do last time, but you should always check out. First, I'm going to just show you that we can run our JUnit test from the command line. Okay. And then I'm also going to show you that we can get the coverage of the system by running this thing called Jacoco. Jacoco is a Java-based coverage system, which basically you can look at the build file, jacoco.build.xml, but it will run our unit test after having done bytecode instrumentation to collect coverage data. Once we've got that, once we've run Jacoco, we can go into the build Jacoco report directory, click on index.html, and you can see the coverage of our system. And this is really nice. You can see that we've covered our database class completely, and you can click down there and you can see all the green parts that indicate the covered fields. And if we go back up to the top, you can see that I wrote no unit tests for the client class, which is kind of bad, and I don't recommend you do that in general, but for the to keep the code from ballooning out of all proportion to what it actually does, I didn't test that side. But anyway, Jacoco is a really useful thing to invoke on any of these systems, because you can instantly see what's being covered and what's not being covered. If we go into the contact class, we can see the hash code field was never actually invoked in this particular situation. Okay, well, that's all I want to talk about today. I hope you enjoy the contact class. You can go to contact service. There are a few exercises that I include in the module associated with REST that enable you to extend this class in a few exciting ways in order to test your knowledge and improve your ability with REST. I hope you enjoy it. Have a great weekend.